Hello everybody, my name is Furkan Mert Aksakal and I am studying CS at Bilkent University. Today I'll be talking about my Physics 102 project. Let me show you how we set everything up. I used two identical horizontal copper wires, each connected to its own DC power supply. The wires were mounted vertically apart using clamps and stands, and the bottom wires was placed directly above the sensitive digital scale. The idea was simple. When current flows, the magnetic interaction between the wires causes a small but measurable force on the lower wire, either attraction or repulsion, changing the scaling ready. I followed strict safety protocols. Since the current exceeded 5 amperes at times, we used insulated gloves and ensured dry and safe working conditions. First, I zeroed the scale. Then I fixed the bottom wire on the scale and suspended the top wire 1 cm above it. The bottom wire carried a constant current of 0.1 ampere. I varied the current in the top wire from 1 amperes to 5 amperes and measured the resulting force by recording changes in mass on the scale. Each current setting was tested 5 times for accuracy. Now let's talk results. I converted the mass readings into force using force equals mass times gravitational force and compared the experimental forces with the theoretical values from the formula. The graph showed a clear linear trend in both experimental and theoretical values, but the slope of the experimental data was slightly less, 15.2 compared to the theoretical 18.0. That difference is due to experimental errors, which we'll talk about next. Even though I repeated the measurements 5 times, I had to deal with several sources of error. First was heating effects. Resistance increased over time, changing the current. Environmental interference, airflow and vibrations affected the ultra-sensitive digital scale. And finally, magnetic interference. The wire's field may have influenced the scale's electronics. To improve, the experiment could be repeated in a vacuum and using a magnetically shielded scale. Also, using a thicker wire with lower resistance and smaller current steps could reduce the thermal effects. In conclusion, the experiment successfully confirmed that magnetic force between current-carrying wires increases linearly with current. While my results were slightly below the theoretical prediction, they still followed an expected trend, with the average percentage error of only 9.99%. This experiment not only demonstrated a fundamental electromagnetic concept, but also highlighted how challenging it can be to eliminate systematic errors in precision experiments. Thank you all for listening.